rahmatullahi wa barakatuh. I don't know why I slept only 3 hours last night, but my classes don't start until 2 p.m. So I have time to sleep. I just have to like get up and pray and like get ready by 1:30. So like I gotta go to sleep right now, like about when. But I gotta take notes first before class. And yeah. That's gonna take at least 2 hours. Yo, Kimberly, how's it going? Oh my gosh, have you been? What have you been cooking? Update me. Let me know how you been. So nice seeing you here. Kimberly. How old are you, by the way? Just curious, because I thought you were really young. Maybe like 14. That's not too young, but like, you're really good at cooking, so I would think you're a bit older now. But I'm not sure. You don't have to answer if you're uncomfortable either. Just saying. I have 51 subscribers. Oh my gosh! Congratulations, Kimberly Cobra! You could finally start live streaming and I could learn some recipes. Did you start live streaming yet? Or no? I'm confused. Why? What's so confusing? Is it the title name? Cause I know that's pretty trippy. But don't be confused, okay? Life is very simple. So for lab 11, we're gonna take some notes. And for part 1, we're gonna do Introduction to Graph Theory. How to stream? I don't know how to stream. Well, it's pretty simple. I mean, if you have a phone, then just press the plus button in the middle, down, like bottom tab, and then it's gonna show you some options. It's gonna make you choose from a video, short, live, post, and probably something else. I'm not really sure. But yeah, you just have to switch the tab towards the live section. And then you just put in the details, like what the title you want, the thumbnail you want, and whether it should be for kids or not. For I'll just put no for kids because otherwise the live stream chat is not gonna work. Nobody is gonna be able to type there. So I don't know how to stream. It won't let me stream. No, that's so sad. I wish I could show you, but I'm using my phone to live stream. So if I had another phone, I could show you. Um, but I don't have one. I could probably charge my iPod and show you, but I don't have the charger for the iPod. Let me see. I have an old iPhone. I'm gonna charge it in the meantime while I take notes, and then I'll show you afterwards. Is that okay? Is that okay? Because I have this iPhone 6 and then this iPod 5. And both of them are dead, obviously, because it's been so long. But I'll charge my iPhone 6. So now it's charging, but make sure to stay tuned until it's fully charged so that I can show you. I will make you my mod. Aw, thank you so much, Kimberly. I hope I have time to join other live streams. It's not like usual for me to join other live streams. Just I'm the live streamer, you know? I don't really watch. But it'd be pretty cool if I could watch you. I'm sure if you did, I would make time to watch it. Inshallah. But yeah, just give it a couple minutes and then I could show you after that. All right.
We can solve a lot more interesting problems. So in this lesson, I'm just going to be introducing a couple of methods that you can see on the web. So the first one is going to be a little bit of graph theory. So introduction to graph theory. So if you've taken the graph theory course, then this is going to look pretty familiar to you. And if you haven't, and if you find stuff interesting, then I would encourage you to take the graph theory course later. So we're going to have to start off with a number of definitions, unfortunately. So first of all, what do we mean by graph? So I don't mean what probably is the first thing that comes to mind, namely some kind of plot of y versus x. So graph theory is a whole special topic in mathematics. So in graph theory, we say that a graph is actually an ordered pair. So it's going to be G as our graph. So it's an ordered pair of some V, comma, some E that's comprised of a set V of
Yo, hey Dreams Big, welcome to the stream. How's it going? I'm a BDS student. What does BDS stand for? Let me see. Business in domestic studies? I don't know. Just a guess. I googled how to stream and it said I have to go to YouTube Studio and go to Feature Advanced. Bachelor of Dental Surgery. Okay, I got that super wrong, but that's so cool. Dental surgery? Yo, you're gonna make bank. Remember me when you make it there, hopefully. And yeah, I hope everything works out for you and you pass all the exams. Yo, Dre, how's your day? Hey, Eriska, welcome back to the stream. How's it going? And my day just started. I didn't sleep too good. I don't know why. I was just, yeah, I slept pretty late for no reason. But yeah, I have to take some notes before class starts again. Yes, my spring break ended, so I have to go back to class. Yeah. The funny thing is when I have class and my whole day is taken up by studying and other things that I don't want to do, I start thinking of things that I normally wouldn't want to do in spring break. Just everything just surfaces from within me. I'm like, this I want to do this, I want to do that. And yeah, when that time comes, you forget all of it. So yeah, I still have a holiday. Oh, lucky Kimberly. Yo, Drea, do you use supplements like protein supplements? Because I got questions. I actually don't. The only supplement that I did used to take was this black seed oil gummy. It's like a halal gummy. Because black seed oil is really, really good for you in sunnah, which means a practice of the Prophet, peace be upon him, in our religion. So yeah, that was the only thing that I took. But that's only because we had it for free. I didn't go out of my way to buy it. And my sister won it from a giveaway, so it was pretty nice. Assalamu alaikum. Oh my gosh, Kai! Wa alaikum assalam wa rahmatullahi wa barakatuh. Welcome back. Oh my gosh, it's been so long. But that's my fault. I wasn't streaming for the past few days. Sorry about that. But I got my new book yesterday. It's called Purification of the Heart and the Soul, or the Soul and the Heart. Something like that. It's by Ibn al-Qayyim al-Jawziyah rahimahullah. So yeah, I mean I read it yesterday and I really enjoyed it. Alhamdulillah. The past few days before that, I was really, really busy, but also I didn't have any content, so that makes sense. Tofu, do you use protein supplements? Oh, Tofu is here too. Alaikum assalam wa rahmatullahi wa barakatuh. Welcome back. How could it be two places at the same time, Kai? She's probably switching apps or something. Studying night 10 to morning 6. Dang! Pulling all-nighters dream big? That's awesome that you're actually dreaming big and working hard for it. But I think like it's bad for your what's the word? Not cardiovascular, your circadian rhythm. Yeah, your circadian rhythm. You probably should study in the morning. I don't know. It's more quiet at nighttime, so I understand why. It's easier to study then. What is the name of the cat? His name is Yuki. Jin Flex? Jin? Uh-oh. Okay, I'll ask ChatGPT. Alright. Tabs, multiple tabs. My Chrome's always open. Awesome.
And sometimes, depending on who you're talking to, what background they have, sometimes you also hear these another term for vertices is nodes. So here they're called nodes. So a set of vertices or nodes and a set E of edges. Sorry about that, I want to take that blue. Okay, what are these edges? So we just say something about them. So where each edge is a two-element subset of V.
Good to know. I'm 13 years old. Awesome. I feel like you told me that before, but it didn't click to me because you said that you're a chef or like you cook a lot, and I was like so impressed. I'm like, a kid can't do that, but so many kids do, and it's insane how talented young people can be if you just invested in them. A bird of what? I'm a bird. What kind of bird are you? You keep cleaning, huh? Yeah. He only cleans himself when he's clean. Like I don't understand it. When he rolls outside in the dirt, he just stays like that. He's so annoying.
So in other words, an edge is going to be connecting two vertices. So you have to pick two different vertices in V, so that's the whole two-element part, and that constitutes an edge. All right, so that's the basic definition of a graph in terms of mathematics definition. So we can talk about different types of graphs. So these edges in the graph can either be directed or undirected. So the edges of a graph may either be directed or undirected.
Guess what I have? Homework. Chai. Oh, awesome. Yeah, I should have guessed that. That's an easy guess. Yeah, tofu, you find out when you grow up a little more. Yuki's head looks so round from this angle. So true, man. Yeah, I know, but not every bird flies. That's true. Penguins don't fly. Kiwis don't fly. Um, there's some birds with wings that don't fly, like pigeons. They take the subway in New York. It's so funny. Homework too, sadly. Aw, it's okay. We have ChatGPT. Alhamdulillah ala kulli hal.
Okay, so two types of edges. And one of the best ways to think about a graph is really just to draw a picture of a graph. So graphs are often drawn with circles for the vertices and either lines or arrows representing either undirected / directed edges. Okay, so let me do a little example here to try to give you a feel for what graphs are. So let's see. So I'm going to have 4 nodes. I tend to call them nodes. I'm going to have 4 nodes in my graph. So I'm going to have node 1, and I'm going to have node 2, and node 3, and node 4. So I have 4 nodes with 4 vertices in my graph, and then I'm going to have some edges. So I'll draw them with straight lines. So there's an edge from 1 to 2, or connecting 1 and 2. There's an edge connecting 1 and 3. There's an edge connecting 3 and 2, and there's an edge connecting 3 and 4. So this will be an example of an undirected graph. So maybe I'll call him G sub U. And he's undirected. So he has 4 vertices and 1.
There's a really loud noise. Going to push something. Wait, Kimberly! That reminded me, my phone is charging. It's at 4%, so I hope the battery didn't go down. So, wait. Okay. Oh my gosh, this is giving me so much nostalgia. Wait, where's my YouTube? I don't have YouTube app. That's crazy. Wait. Dre, do you know the word rabbi means? Isn't that like a Jewish priest? Oh my goodness, the sound too. Older version, no. The stream is like cat lover. It's always zooming in on Yuki. How many chapters left? For what? Like getting a chapter completely done, then getting another. I don't technically have homework, but I try to get my school stuff done before it's time. MashaAllah, I need to learn from you. Bye. No, Kimberly! Don't say bye. I'm downloading this for you. So I can show you how to live stream. How many phones do you use? So I'm using one to live stream right now. This is a really old one. I haven't used this in so long. But I only brought it out so I could show Kimberly how to live stream because she was having some trouble using the app. You're helpful. I'm here. Thank you. Thank you for your patience because the app is downloading. I don't know why I don't have YouTube app. I guess because I used to use Brave for YouTube because it blocks the ads automatically. So yeah. Hey, Kimberly Cobra. I guess in the meantime, we could do our work, I guess.
2, 3, 4 edges. That was just a coincidence. So that's an undirected graph. I could do something similar. So I'm going to do another 4-node graph. So one undirected graph. This would be an example of he's undirected. Him, G sub U. He's undirected.
Goo.
So he has 4 vertices and 1, 2, 3, 4 edges. That was just a coincidence. So that's an undirected graph. I could do something similar. So I'm going to do another 4-node graph. So 1, 2, 3, 4. But now I'm going to do one that's directed. So here I just talked about an edge connecting 1 and 2. But now I'm going to talk about an edge that goes from 1 to 2. So it's going from 1 to 2.
It's still downloading the app. Like, look at that. It's still loading. Nice plain green wallpaper. Thank you. Green was my favorite color. This is so old. Like, the last time I used it was like 2018. So, yeah. Or like, the last time I remember using it.
Going from 1 to 2. And then maybe I've got another edge going from 2 to 3. So I draw another little arrow. And maybe I've got an edge going from 3 to 1. So I'll draw an arrow for him. And maybe I've got an edge going from 3 to 4. Another arrow for him. And then from 4 to 2. So this would be an example of a directed graph. So the edges have direction to them. So this would be G sub D, and he's directed.
G sub D.
Graphs get used for a lot of things in the real world. One of the main uses of them, at least especially in the work that I've done, is for networks.
Wait, did it download yet? What happened? Okay, it downloaded. So let's see how this YouTube Live works. If it works, because this is an older version of the YouTube app. Because my phone is so old, they can't download the new one. Oops. Hopefully my phone doesn't die. It's like barely charged right now. 1 second. Cobra, stay put. I'm getting there. Oh, hopefully. What? Man, the YouTube app's not working. Alright, well, we're gonna have to sign back in then. Oh my god. Imagine I just put in my password on stream. Cat licks too much. Yeah, bro. Almost there, almost there. my phone died. Are you kidding me? No wonder it was so laggy. I forgot that happened. Alright, I'll plug it back in. Hopefully, it'll start up soon. And yeah. Hi, yo, May is here. Welcome back. May, where's June? You mean Aiden, May's sister, right? Are you guys sisters? Her phone died. Move the laptop. Like, towards to see Yuki? He did such a hard work cleaning himself for the stream. Oh, you mean move it from the screen so you can see more of Yuki? Oh, but we gotta study though. Alright, so this is a graph, right? If you look at it closely, we're doing graph theory. So this is an undirected graph. There's no directions, there's no arrows. And this one has arrows, so it's a directed graph. Easy peasy.
Communications network. So maybe these are different, nodes on the internet, servers on the internet that are connected by various paths. Or maybe this is a transportation network. So maybe these different nodes are different cities, and then the edges are the highways linking the cities together. So one big use of graphs is for representing a network. Okay, so hopefully that gives you a bit of a feel for what a graph is. So now I need to make some more definitions so we can talk about the order of a graph. So the order of a graph is, so the size of V. So if you've had some set theory, V is a set of things, and then when I put these sort of like absolute value signs around it, that means the size of V, so the number of elements in that set. So it is, the order is the number of vertices. Okay, so that's one definition. So the order is the number of vertices. We can also define the size.
What happened? Did I mention it's the second time that this happened? How do y'all see the face? My face? It was showing your face? Oh. What are you studying for? I'm studying for, I forgot. I forgot the class name. Wait, let me think. MATLAB. Introduction to MATLAB programming. Don't scare her. Yeah, I already did that so many times, so please don't look too closely. I'm not very careful. Allah forgive me. Should probably wear my hijab just in case. Update required. Oh my gosh, I'm so sorry, Kimberly. I gotta update my YouTube app. It just said, like, download the older version. All the mobile data disappeared then. It's gonna take 5 billion years, bro. Can you stream on the YouTube website? Or, like, does it have to be the app? Because I use the app all the time. I don't think you could use the website. Well, you gotta update it. Yeah. Cha. Can I remember the MATLAB joke? Bro, I had no idea that was an Urdu word. That's why I got so many, like, brown people. Man, this phone is too old. Like, literally look at it when I try to update it. It's like, do you want to update the older version? I press download, it just keeps popping that up. Like, I can't show you, Kimberly. Your old phone is so shiny. I know, right? I keep it in such good condition, bro. Can't believe it's like so many years old.
Of a graph.
Assalamu alaikum wa alaikum assalam wa rahmatullahi wa barakatuh. Faris Imran, welcome back to the stream. How have you been? It's actually been so long. I feel like It's been a week or so. But yeah. Stay tuned for tonight's stream. I'm gonna get back into reading inshallah, and it's gonna be really good with well, what's it called? What's the book called? The Purification of the Heart and Soul by Ibn al-Qayyim rahimahullah. Eating fruits versus drinking fruit juices. Oh my gosh, bro! I literally just sifted strawberry juice today. I blended it up today, and I sifted all the seeds out. I might plant the seeds. I don't know. I've never successfully planted any seeds like from scratch, but um, yeah. I like eating fruits, but honestly, fruit juice is good too if you make it right. I added so much sugar though; it's crazy. But yeah, like welcome back to the stream legitly as well. And laptop air conditioner occasionally. Eating fruits. I got my food. What'd you get?
Is. So if order is the number of vertices, any guesses as to what size it's gonna be? It's gonna be
the edges. Okay. Order is the number of vertices, and then the size is number of edges.
the number of edges. So it's gonna be the size of the set E. So namely the number of edges.
Today I'm not cooking. I'm in my aunt's house. Awesome, Kimberly. But what would you have streamed if you could? Because you can't cook, right? I mean, for now, because you're not in your house. I wish I could show you. Oh my gosh, I'm so sorry. Like, I wasted everybody's time trying to do this thing. Well, it's not my fault this isn't working. It's the app's fault. Or my phone. Okay, it's working now. But you need an account to start live stream. Hello, friend. Yo, it's real, Elisa. Welcome back to the stream. How are you, friend? Hopefully this works before asking for an update. No, okay, it's not gonna work. Banana milk shawarma. I don't know the spelling. Beef kebab. Awesome. Sounds so good. Did I say I had Monte yesterday? I thought I saw her face. Oh. You did though, like. I'm very sorry about that.
Okay, so I'm gonna make another definition. We can also define something called the degree. So both order and size, we're talking about of a graph. The degree, on the other hand, is talking about of a vertex. So the degree of a vertex, maybe I'll call him S, is the number of edges
Connected.
that connect to it. So basically, how many edges are touching a given node? So node 1 here, he's got 2 edges coming into him, so the degree on vertex 1 would be 2. In the case...
Yo, welcome back to the stream, Killer. Wa alaikum assalam wa rahmatullahi wa barakatuh. I was getting surprised that you're Muslim too. Like, I don't know. I just forgot that you were Muslim. What are you crocheting, me? Whoa, making crochet? That's awesome.
Directed graphs, we can talk about whether these edges are coming into the node or out of the node. So we can talk about both the in degree and the out degree of a vertex. So I can also define the in degree. So I'll say respectively out degree, so I don't have to write out the sentence twice. Of a vertex S is the number of edges that enter, or respectively leave. So for the case of out degree, it would be leave. For the case of in degree, it's enter. So it. So for example, in our directed network up here, node 1, he has one edge pointing at him, one edge coming into him. So his in degree would be 1. And his out degree, well, he has one edge.
Cool.
One
Which
edge pointing at him. One edge. Our directed network up here, node 1, he has one edge pointing at him, one edge coming into him. So his in degree would be 1.
And then out degree is 1.
He has one edge going out of him, going from 1 to 2, so his out degree would also be 1. 2 is maybe more interesting here. 2 has an in degree. Node 2 has an in degree of
2,
2 because there's 2 edges
1
going
degree
into
of 1.
him, but he has an out degree of 1 because there's only 1 edge going out of him. So that's in degree and out degree. Okay, so those are a couple of definitions pertaining to graphs, and hopefully gives you a little bit of an idea of what graphs are. So it's all well and good that we can draw a picture of a graph. That really shows you like what it looks like. But if you're trying to do something with programming and graph theory, it's a little bit hard to sort of try to put a picture into your code. So we're going to need a way to represent a graph that's a little more amenable to coding. So we're going to talk about something called an adjacency matrix.
You know what? I'm a crochet laying down. Whoa, she's got skills, bro. So, Killer, how many bad people have you killed? Yeah. He only kills bad people, right? Right? Oh, I forgot. Elisa, how are you? What do you want to be? Do you want to be one of them, Scott? Oh, dear. Well, then I think you need more men to kill me. Yeah, we humbly give that to you, Killer. Hey, Jay. Hi. How are you, Lisa? Yeah, what food did you get, Tofu?
So you can talk about the adjacency matrix of a graph. So it is indeed a matrix. Specifically, it's a size of V by size of V matrix. So however many vertices by however many vertices. That's how big the matrix is. And then where?
Wait, the adjacency matrix is of a graph is the vertices times by the vertices. So there are two types of vertices, or what? Is well, that's a matrix.
So if I write A sub ij, so the ij, like row I, column j, that entry in the matrix, it's either going to be 1 or it's going to be 0. So it's going to be 1 if there is an edge. From vertex I to vertex j. I have to give myself some more room here. Vertex I to vertex j. Okay, so it's going to be a 1 if there's an edge going from I to j, or it's going to be 0 otherwise, so if there's no edge. Okay, so it's going to be a matrix full of 1s and 0s. In programming, what do we talk about? What do we call
Binary.
take on values 1s and 0s? Ah, those are booleans. So our adjacency
Oh,
matrix is
boolean.
going to be a matrix of booleans. So it is a matrix of booleans. Yes or no?
In Islam, that is. Dre, is it a sin to follow every religion instead of following your own one? That's so funny though, cause like, what counts as a sin if you're following all of the religions, right? You'd have to have like a universal sin. But if you're talking about in Islam, then following other religions is shirk. It's kufr. It's not even. You're basically excommunicated from the religion if you follow other ones. I said already, Julia. Oh no, but I can't see your comment. Banana milk shawarma. Oh, I even read it. Oh my gosh, I'm sorry. But yeah, that's awesome. Yeah, that's you're following no religion. Exactly. Yeah, if you want to have a religion, you gotta stand for something. Otherwise, you stand for nothing. But it's nice that you want to follow all the religions. You want to be a universally good guy, and I hope you achieve that. But you have to you have to have those hot takes if you want to be a good person, because not only you're not gonna be able to please everybody, which is sad. I wish I could be friends with everybody or be a completely harmless person, but it's not possible. Because even good people have to defend themselves, right? That's not good then. Exmackily? I just prefer making big projects rather than making little, then getting them together too much work. Oh yeah, that's true. That's true. Yeah, Iman needs to be strong. Make a blanket then. Ooh, crocheting a blanket would be so cool. And then send it to me. I will if I need one. I'm very mad because I want to crochet very fast after sit. Don't be mad. It's okay.
Is there an edge from vertex I to vertex J? So let's go ahead and do a couple of examples of what an adjacency matrix is, or what it would look like for the graphs that we drew up above. So example. Okay, so for our... Oh, I'm gonna need to scroll, bummer. So it says that it needs to be a size of V times size of V matrix. So we'll do our undirected one first. So how many nodes did I have? How many vertices? I had 4, so it's gonna be, our adjacency matrix is gonna be a 4 by 4. Maybe I should just redraw them. Let's do that. Probably take less time and be less annoying than having to scroll back and forth. The graph. 4, 2, again, I didn't give myself quite enough room. The erasers. 3, undirected graph. So here's adjacency matrix. So A sub U. Okay, it's gonna be 4 by 4. So I like to write these as like a from to kind of thing. So from, and then I'm gonna have
Wait, what is A?
A and an edge there. Okay, so that's our undirected graph. So here's adjacency matrix. So A sub U. Okay, it's gonna be 4 by 4. So I like to write these as like a from to kind of thing. So from, and then I'm gonna have like nodes 1, 2, 3, 4. And then 2, and I didn't give myself quite enough room. Maybe erasers. So 2, 1, 2, 3, 4. So it's going to be a 4 by 4 matrix. Okay, so then it's going to be either 1 or 0. So for right here, this is my I equal to 1 and J equal to 1. So is there an edge going from vertex 1 to vertex 1? No, there is not. So that's going to be a 0. So now,
How does it go from vertex 1 to 1?
Is there an edge from 1 to 2? Yes, there is. That's a connection there. How about from 1 to 3? 1 to 3? Yes, we have an edge there. How about from 1 to 4? Nope, no edge there. So now for the second row, we're on to node 2. So how about from 2 to 1? Yes, we have that connection. 2 to 2? Nope. 2 to 3? Yes, that's this edge. 2 to 4? Nope, there's no connection there. And now we're on to node 3. How about 3 to 1? Yes. 3 to 2? Yes. 3 to 3? Nope. And 3 to 4? Yes. All right, last one, 4. 4 to 1? Nope, there's no edge there. 4 to 2? Nope. 4 to 3? Ah, yes, there is one there. And 4 to 4? Nope, we do not have an edge there. So this is what the adjacency matrix would look like for this graph. So if you take a look at that, do you notice anything about it? Especially those of you...
Wait, so 1 to 2, from 2 to 1. 1 to 2. Okay, so it goes both ways. Oh my gosh, Coco, welcome back to the stream. How's it going? And K, please, welcome, guys. It's raining in my place. Oh my gosh, make dua. Even if you're not Muslim, just pray to God. Be like, oh my gosh. I mean, oh my God, like, or like, please God, like, accept all my prayers and stuff. My neck hurts. No, she's not a scholar, guys. She just describes how much she knows. Me? But I know I was expecting you to know more. What? Wait, what did you ask, Killer? Where's Kai Tofu? She's right here. Her name is Jannat Al Ghafur. Drea is a sin to follow. Okay. Assalamu alaikum, Tofu. Assalamu alaikum, K, please. Or, wa alaikum salam, actually. I was seeing the cat in the background. Yeah, I must watch Stephanie Sue's podcast. Ooh, I heard her before. Like, I've seen her videos, like those mukbangs. But yeah, enjoy. You know Sherper? No. Who is Sherper? Where is Bangladesh? I'm bad in geography. Tofu knows. We should ask the Bengali expert here.
Is there anything special about that matrix? Well, you can kind of see that if you sort of like flip the lower triangular part,
Not you, Julia. Okay.
it matches up with the upper triangular part up here. In other words, this is a symmetric matrix. So you can see like this one here matches with this one matches with that one, this one matches with that one matches with that one. So all adjacency matrices for undirected graphs are going to be symmetric. And this is because we don't have directions on our edges. So if 3 is connected to 2, then 2 is connected to 3. So that gives us symmetry. All right, let's try our other graph, the directed one. So I'll go ahead and draw it out again just so we can look at it. So 1, 2, 3, 4. Okay, so 2, and we had 3 to 1, and we had 2 to 3, 3 to 4, and 4 to 2. Okay, so here's a GCC matrix right over here. Okay,
AD.
so again, we have this from 2 going on, so 2, 1, 2, 3, 4, and then from 1, 2, 3, 4. This is from, so it's still a 4 by 4 matrix because I have 4 vertices. So now we have to pay attention to the direction of the edges. So
AG. If you don't mind, not too much work, Kate. Okay, please. I gotta go. Call you Goku.
So is there an edge from node 1 to node 1? There is not. Okay, how about is there an edge from node 1 to node 2? Yes. From node 1 to node 3? No, that one's going the wrong direction, so I have a 0 here. How about from 1 to 4? Nope. All right, on to node 2. Is there an edge from 2 to 1? No, again, that one's going the wrong direction. 2 to 2? Nope, there's not one of those. How about 2 to 3? Ah, yes, we do have that guy. 2 to 4? Nope, again, that's the wrong direction. And now node 3. How about 3 to 1? Yes, that one we do have. 3 to 2? Nope, that one's the wrong direction. 3 to 3? Nope, we don't have that. 3 to 4? Yes, we do have that one. 4 to 1? Nope. 4 to 2? Yep. 4 to 3? Nope, that's the wrong direction. And 4 to 4. Nope, we do not have that. Alright, so that is our adjacency matrix for this directed graph. And so you can see this one here is not symmetric. So it doesn't necessarily, you don't necessarily get a symmetric matrix when you're talking about directed graphs. And it should have been A sub D for directed, not A sub G.
Yeah, so
Instead of
sweet.
D for directed. So those are adjacency matrices for a couple of graphs. There's maybe a couple questions that I could have envisioned people asking. So if you notice on both of them, I had zeros down the main diagonal. So this is because I didn't have any edges that connected like a node to itself. You can actually have, when you're talking about graphs, you can have edges that do that. So I'm just going to, in a different color here. So I could, for example, have an edge. And so certain types of graphs, you can have an edge that goes back onto himself. So then instead of the 0, I would have a 1 in that case. And the other thing that people might ask is, well, what if you're thinking about roads, for example, then the arrow version, so the directed version, so you can think of that as a one-way street. But what if I want to have two-way streets, even though some one-way streets are only one way? So you can actually have another edge, for example, coming back from 2 to 1. So I could draw another edge here, going in that direction, and then I have an edge going from 2 to 1. So instead of 0 there, I would put a 1 there. So you can have edges that look like that. Okay, so that is our brief introduction to graph theory, and you will probably see a question about graph theory and some of these definitions on your lab for this week.
Awesome. Okay, one lecture down. We got 5 billion more to go. Just kidding. There's 4 parts, so we're done part 1. And I gotta do part 2, part 3, and part 4. It's her sister's account. She's studying matrix, guys. Yeah, matrix multiplication for graph theory. So it's pretty straightforward. Like, you make this graph based on this matrix based on this graph, right? And this is a directed graph. This is an undirected graph. And yeah, all these 1s and 0s are Boolean values if it's going from and to these points. So yeah, pretty straightforward. She's studying how to escape the matrix. I wish, bro. I wish I could escape. I could live in the peaceful forest or something. But no.
Welcome back, everyone. In this video, we are going to be doing some math, namely the topic of matrix multiplication. Matrix multiplication. So if you've had linear algebra already, this will probably seem fairly familiar to you. And if you haven't, well, then we do have linear algebra. Part of it will already be familiar because you've seen it here. So what is matrix multiplication? So given an m by n matrix, which we'll call A, and an n by p matrix, which we'll call B, we can define, I don't know what that one was. Okay, we can define the matrix product. So we'll call him C. So he's the product of A times B, and it has to be in that order. So it is it's going to be the M by P matrix with.
Joya, do you watch anime? Oh my gosh, I have a whole, like, playlist, or not a playlist, but, like, this album on Instagram of just clips of different animes that I wish I could watch. And I was planning to watch it over the spring break, but I just didn't. So, I guess the answer is no, but I do remember enjoying it before a lot when I was younger. Like, Gaussian, Parasite, Hitman Reborn, Naruto, Erased. There's so many good ones, bro. Like, anime is really, really fun, but you gotta learn to live in real life, guys. Be right back, guys. Okay. Killer another mission already. Matrix studies. Isn't here a person with a dog profile? Oh yeah, doggy. He's not here. He was here in the last stream though. I don't know if he's gonna come though in this one. I don't know his name. Yeah, doggy. See ya. Okay, bye, Kate, please. Assalamu alaikum. Thanks for tuning in. Maybe he doesn't ban easily. There's cracking jokes now, huh? Good one.
The ij element in this matrix C, so the thing, the number that's sitting at row I, column J, it's given by a formula. So the formula is we're going to take the sum from K.
Okay, so N by P matrix B. We can M by P matrix. Okay, so it's not N by N, it's M by N. Is the M by P matrix with Cij equals the summation.
A equals 1 up to N of AIK times BKJ. So that is the formula for how you get the ij element in this matrix product C. So we're going to be programming that this week. So let's think about this in terms of programming a little bit. So first off, there's two things I want to talk about. So first of all, when we write Cij or AIK, so whenever we have, as a general rule of thumb, whenever we have subscripts in math, what do we have in programming?
Subscripts is rows and columns.
Those tend to turn into matrix or vector indexing. So since we have two of them, an I and a J, a row and a column, that suggests we're going to have a matrix, which is logical since we're doing matrix multiplication. And so we will have like parentheses I comma J. So let me write that down. So
what was it, Coco? If blink is your power, then what are you without it? Oh yeah, that's like your trademark question. What do I do about the person downstairs? Are they disturbing you? Normal person? That's kind of creepy. Is there supposed to be somebody downstairs or no? Imagine there isn't. You just hear somebody. Oops, sorry, I deleted my important thing. I don't know who I'm saying sorry to.
B, we can define, and so we will have which is in parentheses I comma J. So let me write that down. So in math notation, we have C sub I J, so that entry in row I column J, which roughly translates, as a general rule of thumb, which generally translates into C at I comma J in MATLAB. So we have a matrix C, and we're talking about row I as the first index and column J as the second index. Okay, so that's one thing I wanted to mention for when we translate this formula into programming. So what else? We have a summation here. So we've seen summations before. What do we do every time we see a big sigma in math notation? That becomes a what in programming? That is our classic running sum. So also note that in programming, we have one of these summation k equals 1 up to n. That is a running sum. And we want to make it general. We don't know how many terms we're going to have. Well, we know how many terms we're going to have. It's going to be n, but its n could be like the size of the matrix, like it is in this case. What do we use to do this kind of running sum? We use a for loop. So I often call this a running sum for loop. And it's one of these ones where you can literally just take it and say for whatever's down at the bottom of the summation here, so for k equals 1, and then colon up to whatever's at the top of the summation, and then generally the thing that you're doing when you're doing your f sum equals f sum plus something, the stuff here in the summand, that is the something that you're doing when you do f sum equals f sum plus something. Okay, so this translates directly into a running sum for loop. And one other thing that I want to mention is that
That cat is cute. Thanks, Coco. There's petrol, gas, diesel crisis in our country, so it's hard to get these. You should do what what's his name, Monarchist does. Just walk everywhere. But I don't know if the place you're at is a walkable city area, because sometimes it can be dangerous. I'm gonna get my handgun. Ooh, Maze here has a handgun? Is this my boyfriend? What? You have a what? Dang. That's crazy. Oh my goodness. And you got a handgun too. How do you obtain a handgun? That means you have a license probably, right? Or somebody in your family does. That's the world's problem, I think, Tofu. Yeah, it's affecting the whole world. Don't take it seriously because I have been suffering the same situation like you.
you have this running sum. You have a running sum, that is just to figure out what C sub ij is. So just to fill in one slot in this matrix, you have to do a running sum. So you have to fill in all of the slots in the matrix. So you're going to have to do a running sum a lot. So let me say that note that each Cij is a running sum. Okay. So I guess I should probably do an example just so you can see what this looks like, especially if you haven't had linear algebra. So I'll just say, for example, let's say we have the matrix A, which is going to be, it's going to be a 3 by 2. So 1, 2, 0, 0, minus 1, 4. So this is our 3 by 2 matrix. So that's our m by n. And then I've got another matrix B, and it's going to be a 2 by 4. So 1, 1, minus 1, 0, 2, 1, 0, 1. So it's an n by p, and it's a 2 by 4. So if you've had linear algebra, the first question we ask is, can I actually even multiply these two? And so, yes, you are checking to make sure that these two dimensions match. They both have to be the same, they both have to be n. So yes, they're both 2. That's good, we can multiply these. And then what do you get out? Well, it said up here, we get out that a result is an m by p. So the result is going to be a 3 by 4. So that's what we expect to get. And if you do the matrix multiplication, you will get that C equals, so let's see, we get 3 by 4. So I'll just write it out and then I'll explain a couple of the entries. So 1, 1, 4, minus 1, minus 2, 0, 2, 3, 4, and 0, minus 1, 4. Okay, so let's just do a couple of them for example. So let's do this first one. So this guy here, so he is I equals, so the pink one here is I comma j equals 1, 1. So if we look at this formula up here, so we're looking at the case when I is 1 and when j is 1. So what does this say I'm doing? This says I'm looking at my I is 1, so I'm looking at row 1 in my A matrix, and then my k is counting from all the way from 1 up to n. So I'm looking at row 1 in my A matrix, and I'm going through all of the columns. So I'm looking at 1 and then 0. And then in my B matrix, well, my j is the guy that's fixed here, so j was 1, so I'm looking at column 1, and my k is the thing that's counting all the way from 1 up to n. So my B matrix, I'm looking at...
What? I'm not understanding this. What?
You will get...
Hold on. Scott he was my boyfriend. Joya started making me laugh. He heard I was home alone and came over, so I'm not alone. Oh, that's nice of him. It was your boyfriend? You got a boyfriend at this age? Wait, how old is she? I don't know if she mentioned. I think it was only K. Or Kate. What's her name? Kimberly. Can I know? I don't know. Old enough for a boyfriend, I guess. But that's how long. Nobody's old enough for a boyfriend.
I'll just write it out and then I'll explain a couple of the entries. So 1, 1, 4, minus 1, minus 2, 0, 2, 3, 4, and 0, minus 1, 4. Okay, so let's just do a couple of them for examples.
Okay, so 404 negative 4?
4 and 0, minus 1, 4. Okay, so let's just do a couple of them for example. So let's do this first one. So this guy here, so he is I equals, the pink one here is I comma j equals 1, 1. So if we look at this formula up here, so we're looking at the case when I is 1 and when j is 1. So what is this thing doing? I'm looking at A, my I is 1, so I'm looking at row 1 in my A matrix, and then my K is counting from all the way from 1 up to N. So I'm looking at row 1 in my A matrix, and I'm going through all of the columns. So I'm looking at 1 and then 0. And then in my B matrix, well, my J is the guy that's fixed here, so J was 1, so I'm looking at column 1, and my K is the thing that's counting all the way from 1 up to N. So in my B matrix, I'm looking at column 1, and my rows are going from 1 to 2. So to get this entry here, what I'm doing is so row 1 times column 1. So I'm doing 1 times 1, and then I have to add these guys, plus 0 times 1, which gets me 1. So that's where that pink 1 came from.
So it's a row times a column. That's how you multiply matrices. So 1, 0 times 1, 1, and then you add the entry. So 1 times 1 is 1. 0 times 1 is 0. So 1 plus 0 is 1. That's how you get your first entry in the C matrix. And then you do the same for the rest. This one for that one. Oh, actually, I don't know.
So let's do one more. So let's do this guy. So this is when I comma j equals, this is row 2, column 3. So I is 2. So in this formula, it says I'm fixing I is 2. So I'm looking at row 2. I'm looking at all of the columns. And then in my B matrix, my J is 3. So I'm looking at column 3. So I'm going to multiply each of those corresponding entries together. So I'm going to get 2 times 2 plus
negative 1 times 1.
1 times 1, which gets me 4 minus 1 is
3.
3. So that's how we got that 3. So
okay.
That's an example of matrix multiplication. Of course, MATLAB knows how to do matrix multiplication. If you make
Yuki looks adorable. He looks like a panda. Don't call that. Sorry, my internet was another, but the comment seemed like another. What? I just surprised me because I have never been in a relationship. Inshallah, we don't. Like, we stay halal. But yeah. Imagine if she says none of your business. JK, guys. That's true. Let's not get into that. 17, 18 next week on the 24th. Ooh. Happy early birthday, May. But yeah, 17 is pretty, yeah, it's not as young as we thought. So you're gonna marry a man? What? That's so weird. I'm never gonna marry anyone's daughter. Oh, that's true. Like, it does sound gay, but he just wants to be celibate. It means he doesn't want to be in a relationship ever. Tofu, did you just put Coco time out? I feel like he said something weird, but I didn't catch it. So.
A, if you make a matrix B, you can just go A times B. So not dot times, which you properly linear algebra multiplication. So we are going to implement on the lab, we're going to actually implement it ourselves. So pretending you didn't have MATLAB to do it for you, we're going to implement it ourselves using some loops and using this running some formula here. If you want to check your answer, feel free to go ahead and ask MATLAB just what the answer is for A times B, and you can see if you got it right. So that is a short introduction to matrix multiplication.
Okay, so we're done with that. I mean, I've multiplied matrices all the time, but every time I have to do it again, I forget. So now we're doing the Monte Carlo integral approximation. This one is 16 minutes, and then the last one is 15 minutes. Tired, but we gotta finish this, inshallah. I'm just normally tired because I didn't sleep at all last night. Any last words, Coco? Nah, you said you didn't want to marry anyone's daughter. He called me gay. Well, he deserves banned. It's funny though. Welcome back to the stream, Night. Yo, Iran is gone. Rip Iran. What? No way. What happened in Iran? Is something new? Trump warns Iran whole civilization will die tonight unless deal struck. Oh my god, what in the world? A whole civilization will die. Oh, I thought he was saying like he will kill the whole civilization. But he's talking about America. But they didn't do anything, right? He's just yapping. He threatens, okay. He's causing threats or... Oh my gosh. I thought he's talking about America. He's talking about Iran. Oh my god. Okay, back to math. So desensitizing. He called me gay. Show her face. Me? No.
The next topic that we're going to do today is...
Wait, I'm here? Thanks, Air Scott. May you watch your hands before you write anything, okay? Yeah.
The cross between statistics and calculus. So if you think about first-year calculus, what are the two big things that you learn in first-year calculus?
Derivatives.
Differentiation, and then you learn integration.
Yeah.
I know I
Differentiation.
like differentiation better than I like integration.
Yeah.
Integration's just harder, and in particular, some functions you can't find a closed-form version of the integral. So as a result, we tend to do a lot of approximations of integrals. So that's what we're going to be doing now, is something called a Monte Carlo approximation of an integral. Monte Carlo approximation of an integral.
Carlo.
So the idea here is that we want to approximate an integral. So we want to approximate the integral of some function f of x. And we're going to say we know the bounds that we want to integrate between. So some x min up to some x max. So some integral of f of x from x min to x max. Okay, so I'm going to try to draw a picture of a function here. So we're going to do something that we actually know what the answer is, so that when we get an approximation, we can see how good we were in terms of our approximation. So I'm going to try to draw a little portion of a cosine function. So my curve is going to look something like the following. Terrible drawing, so sorry guys. Okay, that's supposed to be part of a cosine function. So this is going to be between minus pi by 2 and positive pi by 2. So our axes here. Okay, so that's our axis. And so this is minus pi by 2. And this is plus pi by 2. So cosine, he's the x1, so at 0 he's 1. So this is a height of 1 up here. And then this is our x-axis, and this is our function f of x. Okay, so that's what we're going to try to approximate the integral of, this cosine function. So f of x is going to be cosine of x, and we're going to take our x min to be minus pi by 2, and our x max to be pi by 2. Okay, so what do we know about the cosine function? So we know that our trig functions, our bound, our sine and cosine, are always bounded between 0 and 1. And then on this particular region, from minus pi by 2 to positive pi by 2, I know that my cosine goes between 0, or sorry, what did I say about earlier? They go between negative 1 and 1. I think that's what I said. Here on our interval minus pi by 2 to positive pi by 2, cosine is bounded between 0 and 1. So we're going to be a little bit more generic, and just like we had an x min and an x max, we're going to talk about a y min and a y max that our function takes on that x interval. So we denote by y min.
Hello. Oh my gosh, welcome to the stream, Naf Yasser. Ahnaf Yasser. Assalamu alaikum. It sounds like a Muslim name. Welcome to the stream. How old is Scott? Who is Scott? If you mean Coco, is probably... Oh, Air Scott. I think Air Scott is like 18, right? Are you not gonna answer? Okay. I feel like he's younger than Tofu. Tofu's like 19. Tofu, I was joking. Persistent? What are you saying, sister? Ahnaf? Is that a girl's name? I feel like I have a classmate named Ahnaf. I'm not sure. I know, I'm half asleep and sick. Aw, I hope you feel better, me. I hate being sick. I'm also half asleep, though.
And y max. The lower and upper bound on f of x on the interval we care about. So the interval x min up to
Oh my gosh, the president. He's here. I hate having sore throat, cough, runny nose, and stomach ache. Ahnaf, a boy's name. I see. Alhamdulillah, you're healthy right now. So you're not going through that. I'm like, I don't know what, like, if I sleep for a perfect 7 to 8 hours, even then I fell asleep in the noon. Yeah, bro. I feel that too. But I don't like naps. Man, I want to go get some clay in the place I was hiking where my stream cut off. There's like wild clay on the ground. I could do pottery with that, but I don't know what cone I would have to fire that in a kiln. But I do want to do that Dorodango thing where you make those mud balls. It looks so freaking cool, man. If I could accomplish one thing, that would raise my self confidence enough to succeed at anything I'd try. The president of the USA is a liar. Hey, he just heard you. Kidding. Yeah, Trump is a liar. He's always joshing or like saying something weird and funny. Such a meme. It's not fit for president though.
X max. And I should probably not use the word the. We should probably say a lower and upper bound would be more proper. So a lower and upper bound on f of x. So cosine, case of cosine, we're going to do 0 and 1 for our lower and upper bounds on our y values. Okay, so when we think about integrals, what do we learn about integration? So for derivatives, we think about slope. For integration, we think about area. So, okay, we're going to start talking about area. So I've sort of defined a rectangle here. So I have on my x-axis this minus pi by 2 up to pi by 2. And then on my y-axis, I have this y min and this y max. Think about a rectangle.
President of the poofers. Oh my god.
So rectangle, something like this. Try being the operative word whenever it comes to me drawing. Okay, so a rectangle like that. And so integrals are like areas. The integral of the rectangle, so the area of that rectangle, I know that one. So the area of the rectangle.
Length times width.
The area of the red rectangle. So the region that we're working on here is, what's the area of a rectangle? Length times width. Okay, so I guess this one's my width. So I need the right one minus the left one. That'll get me my width. So x max minus x min. So that's my width. And then I want to times by my length or my height. So y max in the general case minus y min. Okay, so we know how to find the area of a rectangle. So now we're going to do something called a Monte Carlo approach to try to figure out what the integral of our function is. So in other words, what's the area under the curve for our function? Okay, so...
The cat in the back looks like a dog. Oh, they're so big. Look, Yuki's twitching too. Iris Scott, how do you think I am? Well, I know that. Probably in you're the oldest viewer in the stream. Or like one of the oldest, I think. 20s or 30s. Hi, remember me? Yes. Alex. I do. Welcome back. Okay, enough errors. You need to be humble. See, I'm not the only one with repetitive scripts. That's good. But don't say random people to understand when they grow up, because you don't their age. The cat and... Okay.
Monte Carlo approach. What it does is it performs lots and lots of trials. Okay, trials of what? What do we do on each trial? So where in each x coordinate. So generate, oh dear, that's never good. Let me see if I can fix this. Stay. Okay, see if this still works. So I'm going to try to generate, oh, I think it still works, very nice. Generate a random x coordinate in the range that we care about. So in interval x min up to x max. Okay, so we know how to generate random numbers between some interval. We know how to do that. Now we're going to do the same thing for y. So generate a random y coordinate up to y max. Taking this red rectangle as a dartboard, and we've thrown a dart at this dartboard. And we're assuming we're good enough that we're always going to hit somewhere in the dartboard, so somewhere in this rectangle. So I've thrown a dart, and maybe I hit here, for example. Maybe I've thrown another dart, maybe I hit there. So I'm throwing darts at this dartboard. That's what we're doing by generating a random x and a random y. Okay, so we're going to look at where this point was. So if the resulting point.
Yes, he was definitely saying, but he didn't thought it went inappropriate. Let it go. You're Scott, you're not gay. You're a free individual who likes his own privacy. Yeah. Hey, I didn't use the word gay once. That's true. Yeah, May didn't. Gay's also my as happy. Okay, cool enough, bro. Yeah, nobody's gay here. Alhamdulillah.
So I'll call it x comma y. So the first, and it.
No qamulut. Okay, so if the result.
So if it lies below the curve, so the dirt that we threw at. So I'll call it x comma y. So the dirt that we threw at it. So if it lies below the curve f of x, below the f of x curve, we're going to call that a hit. And otherwise, we'll call it a miss. So I could keep throwing darts at this board. So that one's a hit, this one's a hit, this one's a hit, that one's a hit, that one's a hit, that one's a hit. Whereas if I throw some and they land up here, all these guys, or all these guys over here, these are all misses. So anybody above the curve is a miss, and anybody, I guess I'll say on or below the curve, is a hit. So each trial of our Monte Carlo simulation, I'll throw one of these darts and figure out, was it a hit or was it a miss? Okay.
Welcome back, guys. Assalamu alaikum. I'll leave this topic. Okay, cool. Look at the cat in the back. Looks like a dog. Yeah, it does. You made my phone lags. Wild theory, Coco. Okay. Like phone.
So now, what are we going to do with this? Any thoughts? So we're trying to approximate our integral. An integral is all about area. So we can keep track as we throw these darts, how many ones of them hit and how many of them miss. And if we look at the picture, we should expect the ratio of the number of hits divided by the total number of darts that I throw at the board. So the proportion of the green ones to all of the total darts that I throw, that should be about the same as the proportion of the area under the curve to the area of the rectangle. Okay, so that's going to help us. So since the integral of f of x from x min up to x max is the area under the curve.
So specific, me. Y'all, should I crochet a baby brown bright bull? That's a lot of adjectives. A bull? How do you crochet that? Did you crochet a cat already? You should show us your crochet collection. You got Pixie. All the cats are here. But the president is not happy about this. Why is he being territorial over Yuki? I think he's done.
We have, and if we look at the ratio of the number,
It's Pixie. Pixie dust, yeah, it's like fairy. That's what Pixie means.
of hit trials divided by the total number of trials that ratio should be approximately equal to the area under the curve. Divided by the area of the rectangle. And so this guy, the area under the curve, that is what we want. That's our integral. So these two things, these two ratios, the ratio of the number of good hits divided by the total hits, should be approximately equal to the ratio of the good area, so the area under the curve that I care about, over the total area. So if we took those as an approximation, we could solve for the green one here by just multiplying up this area of the rectangle. So that's essentially what we're going to do to form our Monte Carlo approximation. So thus, we'll take the integral from x min up to x max, and our function f of x dx is approximately integral.
He's stomping. He's so mad. Luca, be nice. Luca. He's so funny. Luca's introvert. He's the quiet weird kid. Oh, look at him. He's so ajib. He's crying. Nobody's even doing anything, Luca. Oh my god. Luca's me. Yes, God, brother, I come here not often. I said that for truly entertainment purpose. I don't know you, so I thought the comment would get a reaction from you, but you're taking it negatively. Okay, that's enough, Luca. That's enough. You're like an ambulance. Is brown cat loafing in bed? I don't know what he's doing. Luca. Luca, Luca. He's crying at nothing. No one's doing anything to him. Luca show. That makes sense. Luca's a cool dictator name. President Luca is doing president things. We won't understand them because we're just. Yeah.
Approximately equal to the integral. So if I solve for this, it's going to be number of hits divided by number of trials. number of hit trials divided by the total number of trials times the area of the rectangle. Area of rectangle. So that is going to be this here, that you figure out how many, you do all these simulations, do all of these trials, you count how many hits you have, so how many of the points landed underneath that curve, divide it by the total number of trials, and then multiply it by the area, which we do know how to, area of the rectangle, which we do know how to calculate, and that will be an approximation of our integral, the area under the curve we care about. And so the more trials that you do, the more darts you throw at this board, the better and better your approximation is going to get. So that's how you can use Monte Carlo approximation to approximate an integral.
Okay, we're done with the third lecture, and we have one more to go. We're gonna make things a lot more interesting. I wonder if he pooped or something. Cause what is he doing? Why is he licking his butt? I wouldn't be surprised if he pooped his pants. Sorry, from how angry he was. Because the Kim Jong Un of cats, yeah, for real. And fixing Nikki are USA and Israel. Kim Jong Un is jealous?
Math, namely looking at what are called Gaussian random numbers. So Gaussian random numbers. So we've seen in MATLAB we can generate random numbers, so we can use the rand function to get us a random number between 0 and 1. So this rand function is using what's called a uniform distribution. And most languages have a function similar to rand that will give you random numbers according to a uniform distribution between 0 and 1. That means that every number, all infinity of them, every number between 0 and 1 is equally likely to be generated by this rand function. Now, if you've had some probability, you'll know that the uniform distribution isn't the only distribution out there. And in particular, another really popular one is called the Gaussian distribution, or it's also called the normal distribution. So what we're going to look at here is how we can use the rand function to generate Gaussian random numbers. So let me write some of this down. So many languages
Calm Luca, fast dressed, I see. I just noticed that. Are you a lefty? Yeah, I am. But I could also write with my right hand, right?
have a built-in rand function for uniform random numbers.
Okay, I'm not that good.
On the interval, open interval 0 up to 1. So it turns out that we can use this rand function to generate Gaussian random numbers. So we can use it to generate
Check if went let out his dictatorship to poop for Nigeria. I'm scared. I'm scared. I don't want to check. I'll let Iron Kale find out. Cause this is her bed. Pixie's cleaning those 0.01% Just Wiki. I know, right? She's so cute. A little bag in one spot.
Gaussian random numbers. When you talk about a Gaussian distribution or a normal distribution, you'll also talk about what's the mean of that distribution and what's the standard deviation.
Whoa, what was that? Was that Yuki? Okay, can you use it to generate Gaussian numbers? Uh-oh. He's bunny kicking her. Don't poop yourself again. Just because they're fighting. This guy is not part of it.
We can generate Gaussian random numbers with a particular mean, meaning the average. So the mean, mu,
No one's talking to you, Luca. Bro thinks he's part of it. We are witnessing a can in front of us. Yo, I'll go eat, then I'll be back. Okay, bye, me. Nobody wants to play. And he's offended. He thinks that he broke up the fight. He didn't. Look at these political leaders, man. Just wanting to fit in.
Deviation.
Yo, what's she doing? I don't know. Luca's me. Aww. Wait, you guys are both orange. That's true.
Just sort of a measure of the spread or the variability of the distribution. So in standard deviation.
With mean? Hey!
Deviation sigma. Okay, so how do we do this? So what we're going to do this is we're first going to generate
Luca. This isn't your bed, by the way.
two numbers from the uniform distribution. So
Yeah, I'm not orange. Your profile picture is. Pixie will mock him right now. I'm old in this channel, I know. She's mocking him right now. Like turning her back behind him. Hey! What? He's getting a panic attack. That's pure mockery. She's like, oh, I'm dead. He's ready for the mission. The killer mission.
let's let
Pixie, stop mocking him. That's so mean.
U1 and U2, so U for uniform, let's let them be drawn independently.
Her low cortisol is gonna be the death of him because his high cortisol is like gonna cause some health issues.
From
He'll surely poop today, Kina. No.
a uniform distribution on 0 up to 1. So in other words, call the rand function twice. Once to generate a U1 and again to generate a U2. So then, the theory tells us, and we're not going to prove that this works, but we can convert them, so that U1 and U2, we can convert.
So many languages have a built-in rand function for uniform random numbers on 0 to 1. We can use it to generate Gaussian random numbers with mean, mu, and standard deviation, sigma. Let U1 and U2 be drawn independently from a uniform distribution on 0 to 1. We can convert them into...
Convert those to samples from our Gaussian distribution, which is usually denoted, so it's got a fancy n of mu comma sigma squared, using some formulas. So what are we going to do? We're going to calculate an x1. So x1 is supposed to be drawn from a Gaussian distribution. So how do we calculate it? Well, the formula is going to tell us we should do sigma times the square root of minus 2 times the natural log of u1. So that's all under the square root. And then we're going to times by cosine of 2 pi times u2. And then lastly, we're going to add on the mean for the Gaussian distribution that we would like. So that's how we calculate x1. And then x2 is going to be very similar. x2 is going to be sigma times the square root of minus 2 times natural log of u1.
I'll bring cookies in the next life. No cookies for Air Scott. No. Okay, I'll have to go to sleep. Bye. Okay, bye, Coco. Have a good sleep. Where are you from? Are you also from India like Air Scott? Well, I'll bring my own best cookies than yours. Ooh. Air Scott came prepared to the afterlife.
That's all into the square root. And here we're going to times by the sine of 2 pi u2. And again, we'll add on u. So we're going to generate u1 and u2 that were uniform and convert them into a pair, x1 and x2, that were drawn from a Gaussian distribution. So if we want to generate a bunch of numbers drawn from a Gaussian distribution, we could just repeat this process over and over again, just generating pairs from the uniform and converting them to pairs from the Gaussian. So we can do this. Do this for a bunch of samples. And so then all of these x's should be distributed according to a Gaussian distribution, if this process actually works. So we might be interested in seeing, well, does it look like it works or not? So one of the things that you do if you're working with...
You're not the only one who has this talent, bro. How can I bring cookies? I'm the real Coco. Because cookies can't be made without some chocolate. And you need cocoa in your chocolate. Dang, that's so deep. I'm multi-talented. Oh, whoa. Oh, come on, Eris, kids. I mean, fighting over cookies? Kid isn't an offensive word. Yeah, it could be endearing. But it's also demeaning. I'm still trying to see if this works, even though Kimberly is gone. Oh, whoa! Oh, never mind. But yeah, what other talents do you have than making cookies, Air Scott?
The probability is you'll often plot the distribution. So you probably see...
We'll do this for a bunch of samples.
In a plot of the Gaussian distribution somewhere along the line, it's sort of your standard bell curve if you've seen it used for curving. So what we might want to do is once we've generated a whole bunch of these x1s and x2s, generate a whole bunch of them, we can plot what's called a histogram of them. So basically the idea of a histogram is you take the x-axis and you divide it up into little bins and you figure out how many of these x1s and x2s fell into each of the bins. So we can then produce what's called a histogram, which gives a count of the number of Gaussian samples falling within each bin in some partitioning of an interval that we care about. So I'll say x min up to x max. Okay, so let's take an example here to see what we mean by this. So for example, maybe I want to look at an x min value.
Partitioning of x-min and x-max.
Of minus 5 and an x max value of plus 5. So now I want to show you what the histogram bins look like for this interval. So in particular, we're going to use a bin width of 0.5. So if we were to do that, so I've drawn this out ahead of time because it was going to take me a number of tries. So let me paste this in. So what you've done here is you take
I'm
out
slowly
the
learning cooking. Awesome. What did you cook today? Or yesterday or recently? Are you dancing and sketching too, Eris? Dancing? Whoa, that's so cool. Dance like soda pop.
axis, and in particular the interval that we care about, -5 up to 5. And I've divided it up into little bins. So each bin has a width of 0.5. So this first bin, so bin number 1, the labels of the bins are down on the bottom, is between -5 and -4.5. Then the second bin is between -4.5 and -4, and so on and so forth, all the way up to the 20th bin is between 4.5 and 5. So as we generate these x1s and x2s, we can count, we can figure out which bin it lies in, and then keep a counter of how many of these x1s and x2s fell within a given bin. And then we can plot that, where the height, the y value for the bin, is going to be how many of the x's fell into that bin. Next two, we need to figure out what bin each one of those is in. So if you use a bin width of 0.5, then, so any one of these x1s, x2s, as you repeatedly generate them, if you want to calculate the bin number is given by a formula. So it's going to be b, so bin number, here it's going to be between it's going to be between 1 and 20 if you're working from -5 up to 5. So the bin number is going to be, so you calculate the floor of 2 times x minus x min and floor, and then plus 1. So as you generate all your samples, x1 and x2, you plug them in, each of them individually, in for x, and you subtract off whatever min is for this interval that you want to work with, and that will give you a bin number. So then you can say, I have found one that was in bin, so for example, if I generated, say, 2.75, I would plug the 2.75 into this formula with an x min of -5, and it would tell me that 2.75 is in bin 16. So I would say, great, I'm going to increment a counter saying, I got a sample that was in bin 16. So if you do this for all of the samples, you can then take all of these counts, so for each of the bins, you'll have a count of how many of the samples fell into that bin, 2.75, and it would tell me that 2.75 bin will give you a bin number. So then you can say, I have found one that was in bin. So for example, if I generated, say, 2.75, I would plug the 2.75 into this formula with an x min of -5, and it would tell me that 2.75 is in bin 16. So I would say, great, I'm going to increment a counter saying, I got a sample that was in bin 16. So if you do this for all of the samples, you can then take all of these counts.
How's it been 16? Is she just giving it like a random thing? I played the piano last when I posted a video. Joya saw that, I guess. Oh yeah, that was a long time ago. But how did you learn? Did you have like a teacher or you just self-learned? Tofu, you're a man, as I am, and you know a man does not like being insulted.
Count of how many of the samples fell.
He's just starting stuff. Like, what is he even doing? Luka. He's gonna poop from frustration. Pixie is so secure. Like, she knows no one could touch her.
Into that bin, and you can.
Like, she just lifts a finger and he gets scared. Like, he's such a coward. Mating? No, mate. He's just being dominant. They're both neutered and spayed. She's spayed, he's neutered. He's just being territorial again.
Plot those. So if we plot the histogram, so for every, on your x-axis is basically going to be the partition values here, so -5 up to 5, and that's corresponding to the different bins. The y value is going to be how many were in that bin. If you plot that histogram, any thoughts as to what it should look like?
It should look like a bell curve.
Well, if you jump.
Welcome back, me. President! Get back, Mr. President! Presidents don't go first hand in these things. Thank you. We'll take care of it. Don't worry, Mr. President. He's so mad. He's literally thumping. I felt offended when he called me that. I don't understand why, just because I value my freedom. That's true. I mean, it's not that common these days that we find someone who takes these things seriously. It's like kind of like banter, you know, like people they just joke around. They don't really mean it. But that's true. We shouldn't joke around like that. Also felt he went too much. Hope he gets that from later or on, or he'll get timed out for sure. Yeah, I think he learned his lesson. Cool, cool.
Generating, say, Gaussian random numbers that have a mean 0. If you've seen the Gaussian distribution, it kind of has this big bump in the middle. So it looks something like a big bump. It's a big bell curve. And so as we look at the histogram, that means that we should expect to have more, so higher counts, in these bins that are around 0. So in other words, if our y value is going to be how many we got in that bin, we should expect more around the mean. And in particular, that should hold for all the rest of them as well. So if we plot this histogram, it should look like the Gaussian probability density function. So we plot the histogram, it should look like the Gaussian probability density function. So we're going to be doing that on this week's lab, and so we're going to see how well does this process work. We're going to see whether or not our histograms look like that nice, familiar bell curve or normal distribution curve, Gaussian distribution curve, whatever you want to call it. We're going to see how well this process does and how well that histogram looks like that curve.
Yay! We're done watching all the lectures. But now we gotta start with the lab. So we have this lab 11, right? We're just gonna bro, my boyfriend selling food. Wait, what food? I also felt me got no context. Put a diaper on Luca. I know. I don't think he did anything though. I would have smelled it by now. Yeah, your boyfriend must be a what? I did not read the whole thing. I'm kind of glad I didn't. Must have been bad. Oh my gosh, this is such a huge lab. It's only 5 questions though. You're so rude, Scott. What did he say? So you were too, mate. Oh, he's mad that you call him gay, so now he's getting you back. So when people call you gay, it's not okay, but when you call other people gay, it's okay. Can't anybody appreciate how peaceful I am lately? I appreciate you, Tofu. But yeah, no throwing around the word gay, guys. It's a very serious sin. People get stoned. I said sin, not Siri. When I said serious, Siri was like, hello. Dang, this phone is so old. I haven't heard Siri, like, in so long. And how's my boyfriend gay if he can cook good food? Bro, that reminds me of the AOT couple. Attack on Titan, Sasha and the guy. He just gave it back to me, but I'm not sure you called her that or no. It must be Coco. Alright, so we're gonna start on the lab. We got a new script. Lab 11, question 1. Man, I hate how in the lecture she just goes over the concepts, doesn't go over the code, how to do it. Like, it's supposed to be that much of a problem-solving class. I don't like that. I want the solutions. I don't want a puzzle. This type of, like, class is fun for people who like Rubik's Cubes. Okay. Yeah, that's what I'm telling I see you, May, so. Okay. No more calling people gay. Like, you hinted that he's gay, and he's saying that your boyfriend is gay. So now they're equal, right? Okay. So let's take a look at this question here. It's crazy that tofu is the most peaceful today. It's usually Eriska and tofu, but now it's me. Okay. It's like Luca and Pixie. Like, that's how y'all are yapping. Or doing. Okay. Let's go over this lab assignment, shall we? So for each question, create a separate MATLAB octave wait with the file name. And yeah, so direct below the first name and last name. Alright, so number 1, for a directed graph, the in degree of vertex j is the number of edges coming into the vertex j, while the out degree of vertex I is the number of edges leaving vertex I. So that's what we went over in the lecture. So the degree of a vertex is the sum of the in degree and the out degree of the vertex. It's the sum of in and the out degree. So that's the whole degree. There's an in, there's an out, and there's a degree. So write a program that obtains from the user the number of vertices in a directed graph by calling the function getNumber of vertices, which should prompt the user for the number of vertices, check if an integer greater than or equal to 2 was entered, and print an error message using %d if it was not. Return the entered. Okay. So first we're going to prompt the user for the number of vertices, right? So we're going to write a header function and valid get number of vertices, right? N is our output, valid. We're going to check if it's valid, and that's our number of vertices, N. And then check if an integer greater than or equal to 2 is entered. So it has to be valid. So if valid equals 1, then A equals Randy 0 to 1 and N. So this is the part where it's talking about validity. If a valid number was entered, the main program should then use Randy to generate a random adjacency matrix for the specified number of vertices. The main program should then call a function print matrix, which should. So we're gonna need to call print matrix right here. The random adjacency matrices and are y'all getting this? What do you mean by rage baiting peak moment? Yeah, you should be like that. This to me. I'm done with this convo. I'm peaceful for 2 weeks now. Come on. What happened? For 2 weeks you're so peaceful. Allahumma barik. Allah always make you peaceful. I say something rude, but I'll get kicked. Yeah, better not say it. I cut the inside of my mouth somehow. Oh no. Good for you? Oh my gosh, Aries, that's so rude. Okay, I'm gonna let y'all take a break, inshallah. I'm gonna end the stream. And then, yeah, we could continue streaming later. Okay, bye guys. Assalamu alaikum.